You throw a ball off the top of the school 15 meters above the ground with a velocity of 20 meters per second, and this is at an angle of 30 degrees above the horizontal. What is the maximum height achieved by the ball? As usual, we have our picture drawn. Here's the building, 15 meters high. There's someone throwing the ball. 20 meters per second is our hypotenuse. Velocity in the x is in red. Initial velocity in the y is in green. And what we're actually going to be solving for here is the maximum height. So we're not going to use this negative 15 for displacement because we're not interested when it gets to the ground. The question is not saying how far away does it land, nothing like that. The question is, how high does it go? I want to know where there is. So in reality, what we're trying to solve is that displacement in the y direction from the ground up to the top of the building. So pulling my numbers out, the stuff that we have so far, displacement in the x, I don't know. I don't know where it's going or how far away in the x direction the maximum height is going to take place. Velocity in the x, we'll solve for that in a second, doing our right triangle stuff. In the y direction, we're trying to figure out how high does it go. The initial velocity we'll find in just a second, doing our right triangle, and we know that the acceleration is negative 9.8 meters per second squared. Something else we know, which is important, at the maximum height, the object has to stop going up before it can start coming back down. So we know the final velocity in the y is 0 at that point right there. So now we're going to set up our right triangle to solve for the velocity in the x and the velocity in the y. Velocity in the x is the adjacent side, so I solve for that using cosine, 30 degrees times the hypotenuse, which is 20 meters per second. And when I do, I find that the velocity is 17.3 meters per second. Doing the same thing in the y direction, except the y is the opposite side, so velocity in the y is the sine of 30 degrees times 20 meters per second, which means the initial velocity in the y is 10 meters per second. So now we know the initial velocity in the y, right here, 10 meters per second. In the x direction, we have 17.3 meters per second. This is actually an interesting problem in that we don't have to solve for time in the x to get the thing that we really want in the y, because we have 3 numbers already. The difficult part of this problem is just knowing what you're trying to find, knowing how to draw the picture and the setup, since we're no longer worrying about it here, we're worried about it up there at that maximum height. So I'm going to pick the equation actually that doesn't have time in it, because that's the thing I don't know. So I'm going to pick the VF squared equals V naught squared plus 2AD equation. I'm solving for D. So to solve for D algebraically, I'm going to subtract V naught over to the right side first. So minus V naught squared equals 2AD. Now I'm going to divide by the 2A, leaving me with VF squared minus V naught squared all over 2A equals D. I can plug in my numbers. VF was 0, so that leaves me 0 minus V naught squared, which is 10 meters per second, squared all over 2 times negative 9.8 meters per second squared equals D. And when I plug in to my calculator, I will get 5.1 meters. That's how much higher it is from where it started. So if I add in the 15 meters of the building, the maximum height would be 20.1 meters.